Okay, so I'm going to start recording. Here is the fractions on a line plot that some of you were having trouble with. I just wanted to show you my version of it, and hopefully I can walk you through it. It may not be the same, but it's similar.
Online adventure. Geo's our guest host for the day. Geo, have you seen anything interesting lately?
Yeah, I saw a site for the gross games. In one of the competitions, the contestants have to carry this gross green ooze stuff across the room using a cup attached to the top of their heads. It looked disgusting.
Let's check it out.
Here are the results of the green ooze carrying contest.
Let's organize the information on a line plot.
Use the number line to create a line plot of the results. Drag each X from here.
Okay, so all it wants us to do is use the number line to create a line plot of the results. So all we're doing is we're using our chart for our information and we're putting it on our line plot using the X. So Kaya has 3/8, so we're going to take this X. We're going to drag one of our X's over to 3/8 for Kaya. Avery has 5/8, so we're going to grab another X, drag it over to 5/8 for Avery. Eli has 1/4. I'm going to drag an X for Eli. Pablo has 1/2. Taryn has 5/8. Oliver has 7/8. Sunga has 3/8. Saki has 1/2. Lorraine has 5/8. And Dale has 1/4. That's all we're doing is plotting our data. That is all that they wanted us to do.
Right on.
Says, make a line plot to display a data set of measurements in fractions of a unit. That's exactly what we did.
What is the greatest amount of cups of green ooze any one contestant carried?
Okay, they want to know what the greatest amount of cups of green ooze any one contestant carried. So these X's represent our contestants. So the greatest, which means the largest amount that any one of these contestants carried. So the X that we have the furthest down on our line plot would be 7/8.
That's what's up. The greatest value that has an X above it is 7/8. So the greatest amount any one contestant carried is 7/8 of a cup. What is the least amount of green ooze any one contestant carried?
Okay, the smallest amount of ooze that any one contestant carried. Obviously, we have smaller amounts on our line plot, but our X's represent who carried what. And the smallest amount that anyone carried is 1/4.
You know it. The smallest value that has any X's above it is 1/4. So the least amount anyone carried is 1/4 of a cup.
Yep. And since there are two X's marked above 1/4, that means two people carried 1/4 of a cup of green ooze. Yuck.
How much green ooze was carried in all? Use the slash key if you want to enter a fraction.
Okay, so how much ooze was carried in all? We want to look where our X's are. So we have two contestants that carried 1/4 of a cup. So 1/4 times 2 over 1, because we're turning a whole number into a fraction. So we put it over 1, and then we multiply straight across. So let's keep 2/4 in mind. We also have 2 that carried 3/8. Okay. We have 2 that carried 1/2. 1/2 plus 1/2 is 1 whole. We have 3 that carried 5/8. We're going to leave it like that for right now. And we have 1 that carried 7/8. Okay, so I'm going to organize this a little better so that I can add them all. Now that I have all my information. Okay, so we have to add them, but first they have to have like denominators, which is our bottom number. We've got 1 that doesn't. Oops. So we want to make this 4 into an 8. So what do we have to multiply that number to make it into an 8 to match these other ones? Okay, and what we do to the bottom, we do to the top. So our new fraction is 4/8. So we'll start with 4/8 plus 15/8 is going to be 19/8. 19/8 plus 7/8 is going to equal 26/8 plus 6/8 is going to be 32/8. We'll save our 1 for last. So that's an improper fraction. How many times will 8 go into 32? 4 times, and there's none left over, so it doesn't have a fraction left over. It goes in equally, but we still have our 1, so 4 plus 1 is 5. So let's see, 5 cups total. Let's see if we're right. Oops.
Right on. Find the amount each contestant would carry if the total amount carried, 5 cups, was redistributed equally among all the contestants.
Okay, so they're saying let's take our 5 cups, and instead of everyone having a different amount, we want to give them all the same amount. So we have our 5 cups of ooze, and how many contestants do we have? Do you remember how to figure that out? The contestants are our x's. So how many x's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be, we're going to divide 5 cups amongst 10 contestants. So there's a couple ways to do this. Okay, so when dividing fractions, you want to keep change flip. You keep the first one. You change the division into multiplication, and you flip this fraction. Now we can multiply straight across. 5 times 1 is 5. 1 times 10 is 10. and that can be reduced or simplified. What can go into 5 equally, that can also go into 10 equally. 5. So 5 divided by 5 is 1, 10 divided by 5 is 2. So if we divided 5 cups amongst 10 contestants, they would each have half of a cup of ooze.
That's what's up.
This math is awesome.
Remember the animal games? Well, they've decided to add an event. Worm wrestling. Can you believe it?
How does that even work? I mean,
Well, they're divided into categories by length. You know, to keep it fair. Check it out. The lengths of the worms in inches are listed here. Which line plot shows this data?
Okay, so a way you can find this out is making your own line plot. And plotting your data. All of them start with 3/4 and end with 1.5. So that's where we will start. Seven eighths, 1 1 1/8, 1 1/4, and 1 3/8. Mine's a little messy, but I can read it. Okay, so our contestants up here, our little worms, are at the top, so let's start plotting. Okay, we have a 1, so let's put an X above our 1, just like we were doing with the last cups of ooze. 3/4, put an X above 3/4, 1 1/2, 1 3/8, 1 1 1/2, 1 1/8, 1 1 3/8, 1 1/8, 1 1/4, 1 3/8, 1 1/2, and 1. Okay, so we want to find a graph that looks like this. So let's see. 1x over 3/4, they all have that. No x's over 7/8. That takes this one out. It's not going to be this one. They have an x above 7/8, and that is not in our data. We have 1, 2, 3, 4 x's above our 1, which rules us into this top one for worm length.
Slide-a-roo. Click on the length of the shortest worm.
Okay, the shortest worm. Remember, it's not always going to be the smallest number on our line plot. In this case, it is, because it has an X above it. So our shortest worm is 3/4 of an inch.
Awesome sauce. The smallest value that has an X above it is 3/4. So the length of the shortest worm is 3/4 of an inch. Click on the length of the longest worm.
Okay, again, the longest may not be the highest number on the line plot. In this case, it is. There's X's above 1 1/2, which would be our longest worm.
Right. The greatest value that has an x above it is 1 1/2. So the length of the longest worm is 1 1/2 inches.
What is the difference in length between the shortest and longest worm?
Okay, so our shortest worm is 3/4 inches, and our longest worm is 1 1/2 inches. And we have to find the difference in length. So first, you can't just line them up and subtract. We need like denominators. And first we need to turn this into an improper fraction. So 2 times 1 plus 1. So 2 times 1 is 2, plus 1 is 3. And then you put that over 2. That's our first step. We still cannot subtract 3/4 and 3 over 2. So we need to turn our 2 into a 4. So what would we multiply that by to turn that into a 4? A 2. And what we do to the bottom, we do to the top. So now we have 6 over 4 minus 3 over 4. 6/4 minus 3/4 equals 6 minus 3 is 3, and we keep our denominator. So that's our difference between the shortest worm and the longest worm.
You know it. 1 1/2 minus 3/4 equals 3/4.
That just shows my work.
Complete the sentence. The longest worm is times as long as the shortest worm.
Okay, so you can take a look at this. Here's our shortest worm, and here's our longest worm. 3 times 2 equals 6, which would be our numerator. So it's 2 times as long as the shortest worm.
Right on. 1 1/2 or 6/4 is 2 times as great as 3/4.
Awesome sauce! Aw, man. Sounds like it's gonna get pretty wet out there, and I totally forgot my umbrella. My hair does not do well when it rains. Did you know there are places where it hardly ever rains? Check out these average monthly rainfall amounts for my dream place to live. Click on the greatest amount of rainfall.
Again, we're looking for the greatest amount with an X above it.
Right-a-roo. Click on the least amount of rainfall.
Least amount with an X above it would be 1/8.
Awesome sauce. And that happened 3 months out of the year. Those are happy hair months. What is the difference between the greatest and least amounts of rainfall?
Okay, the difference between
If you want to enter a fraction, leave the whole number box blank or enter a 0.
Okay, so the difference between the greatest and the least amounts of rainfall. So the least amount is 1/8, and the greatest amount is 2. 2 whole inches. 1 whole inch would be 8/8. So 2 inches is going to be 16/8. So the difference is going to be 1 minus 16. Sorry, 16 minus 1. So it's going to be 15/8. Improper fraction, we need to turn it into a mixed number. So how many times will 8 go into 15? 1 time with how much left over? With 7 left over. 7/8, because that's our denominator. So 1 and 7/8 is our difference.
Well, that was totally calculicious. 2 minus 1/8 equals 1 and 7/8. So the difference between the driest and wettest months is 1 and 7/8 inches of rain. Complete the sentence. The greatest amount of rainfall is times as great as the least amount of rainfall.
Okay, again, our least amount is 1/8. The greatest amount, this was the number we wrote. So to get this to this, it would be 1 times 16 equals 16. So that means it's 16 times as great as the least amount of rainfall.
Well, that was totally math-tacular. 2, or 16/8, is 16 times as great as 1/8.
Find the sum of the average monthly rainfalls. Use the slash key if you want to enter a fraction.
Okay, now we're adding all the monthly rainfalls, which are only the ones with the X's above them. So 1/8 has 3 months. One-fourth is 2 months. Then we have 5/8, 7/8, 1 and 1/8, 1 and 5/8, 1 and 7/8, and 2 under 2 inches, so that would be 4. So let me start with this 2/4. Let's turn it into an 8. And let's get rid of some of our information here so we don't get confused. Okay, we'll start with 4/8 and 3/8. So there's a 7/8. Erase it as we go. 7/8 plus 5/8. 12/8. 12/8 plus 7/8. 19/8. Now we got to turn these into improper fractions. 8 times 1 is 1, plus 7 is 15. Like I said, there's many ways to do this. This is just how I'm doing it right now. So 15 plus 19. 34/8. these 8s, we can also just take these whole numbers away and put them into the 4. So 4, 5, 6. And then we'll just add the fractions to the one we have going over here. So 1/8 plus 34/8 is going to be 35. And then 5/8 is going to be 40. And don't forget about our whole number over here. So we need to turn this into a whole number or a fraction. How many times will 8 go into 40? 5 times. There's nothing left over. But let's not forget about our 6. So 5 plus 6 equals...
That's what's up.
Only 11 inches of rain in the whole year? That'd be hair-tastic. Some of the wettest places get 11 inches in 1 month.
How much would it have rained each month if the total amount...
Okay, so we want to divide 11 inches into 12 months.
Right on. 11 inches of rain divided by 12 months equals 11/12 of an inch of rain per month.
Fancy factoid. That's just under 1 inch per month. That amount could come down in 1 or 2 good rainstorms. I'd hardly ever have a bad hair day.
Use operations with fractions to solve problems including data presented in a line plot.
Well, that was totally calculicious. I wonder what would happen if you used some of that green ooze as hair gel. To the internet and beyond!
Okay, so that was the end. Yours is going to be similar. Use similar operations to solve your problems for fractions on a line plot. If you have any issues, go ahead and contact me and I can help walk you through it. Hopefully this helped.